Hello, I'm Niklas, and I'm a torrenter. So I've started out torrenting way back when, well, I started with file sharing with like LimeWire and when those things were popular and you downloaded MP3s and you got lots of viruses and all that good stuff. And I just never stopped. Like services like, Spotify and Netflix, they do a lot of good things, but they don't reach quite there for me. They don't provide everything I want. So I started torrenting, and quite a few friends of mine are torrenting, and we've scaled it up a bit. So basically, we have created a large-scale decoupled torrenting system, I guess you could call it. Started out with single machine, which was just, you have drives, you have a torrent client, you download, simple as that. But then that didn't quite reach the capacity we were wanting, so we have scaled it up, and currently the system has separate components. So I tried to split it up as much as possible because, containers are fun, VMs are fun, and just see what you can do with these technologies and torrenting. So for this system, what I've done is split everything into three. There's a dedicated file server, which has just a lot of drives. And I think currently the server has 26 drives or something, but that's a shared file server that multiple people are using. And then I've set up networking, which is run on a different location from the file server. And then on a third location, we're running a virtual machine host. So for the networking, basically what's been done is setting up a VPN server. This you can do on a VM container or a physical host. Really doesn't matter. I've underlined physical host because that's what I'm doing. VPN server might be a bit strong. It's like a powerful ASUS router that just like home router. For the file server, you don't want to move the entire file server into the VPN network because you want to have it available in multiple places. So what I've done there is that I'm running a small VM host on the file server as well, where you create virtual machines and you just push file systems into the virtual machines. And those virtual machines you can place on various VPN networks, and thereby exposing basically the file server to the virtual networks in various places. And this you have to do on a VPN. Well, you could maybe do it with a physical host, but for containers, this wouldn't really work because containers are supposed to be stateless, and this is very much stateful. That's the entire purpose. And there are bugs that have occurred, like especially Docker has issues if you try to write a lot to the containers. The file drivers don't really handle that too well. Might work well for a long time, but then you might get issues. And the VM host is what's hosting the actual torrenting application. And this you can use a container for. That's what I'm doing. You can use the VM if you want to. And the client I'm using is rTorrent. It's a very powerful torrent client. You can do a lot to configure it. It has a lot of APIs, and the client itself is command line only, but you have a lot of GUI clients that can use the API, and you just use those separately. And with these, basically you have one client that is running from 3 different locations, and it works surprisingly well. So for the VPN server, I'm using OpenVPN, which is just normal open source VPN software. And on this, I've created a virtual subnet. You can create as many as you want to, doesn't really matter. But in this is a virtual subnet that is only dedicated to this system. So there's no other clients running on this subnet. And what I've done is made a dedicated virtual IP for each of the services. There is probably a better way to do that, because well, this is a home project. So I've scripted basically the servers to check which IP they get for the VPN, and if it's the wrong one, try to connect to the VPN again. So they just cycle through the entire IP space looking for the correct IP, and then when they get it, they just stay there. You should probably do it, if I was to do it again, with DNS, most likely. That's for the future, though. And the VPN server is running on an ASUS router with custom firmware, just because it's awesome. For the file server, I'm hosting it on Linux. I'll talk a lot about this later. And I'm running a distribution called Proxmox based on Debian. And it's basically a distribution intended for data centers. Like, you can have one distribution of this, where you run VMs, you run file sharing, and you can connect multiple instances together, located in different places. And you can also move virtual machines between the instances and containers. So if I have one Proxmox instance in one place and someone else has another one in another place, I can run my service on my Proxmox instance. But when I need to do some maintenance, I can just move it to his instance, take mine down, do whatever maintenance, and then bring it back up and move the VM or container back, which is great for uptime. I think I have some virtual machines with higher uptime than any of the physical hosts, so that's cool. And major point is that ZFS is well supported. ZFS is one of the next generation file systems. Currently, ZFS is the most mature one. You also have one called ButterFS. And they are the first type of file systems that do like error recovery. If you have sectors going bad and files being corrupted, they will attempt and very often succeed in recovering that, while other file systems like NTFS will just let that slip. So if you have a good example that someone tested was that they had a picture and they flipped one random bit and tested, opened the picture on NTFS, ZFS, and ButterFS to see like what happens. And on NTFS, the entire color scheme for the picture got switched, so you had like a blue tint on the entire picture. ZFS opened it as it was intended, it just corrected the error, and ButterFS crashed the entire system. So ZFS is the more mature one, but maybe in a few years ButterFS will get there as well. The major differences between them, apart from a few technical differences, is that ZFS is, well, it used to be Oracle licensed, so you can't bring it into the Linux kernel without infringing on copyrights. So ButterFS is compatible with the Linux license, and as such can be supported by the kernel natively. Yes, and it also has an amazing UI that, my grandmother could have used, so that's always nice. And there are good command line tools, so you don't have to use the UI if you don't want to. You can also do most things in the command line. And on this, I just use the VM to basically, yeah, okay. I'll get back to that. Oh yeah, I use the VM to serve files to the torrent server. So that's just a very, very small VM instance, like 64 megabytes of RAM. That just its only purpose is to go into the network that has the OpenVPN server and serve files there. Does nothing else. So for this image that I call the NAS image, I've used Arch Linux. It's tiny. It doesn't contain anything you don't want. ZFS has something called datasets that I'll get back to, which are basically, think of it like folders that have properties recursively inwards. Like you can set a limit that, okay, this folder should only have be allowed to write 10 gigs of space. And you can lock down basically a data set. And this image also has an SSH user. I've chosen SSH as the way to share files. That can be discussed because SSH isn't really intended as a file sharing protocol. It just works really well for it. But you have others like NFS, which I've had some issues with. But that's probably due to misconfiguration, but SSH is very easy to set up as well, so it limits the amount of configuration you have to do. And this only has read-write access to that data set. So the SSH user cannot execute files, which is important, because if someone were to get access to this user and SSH into the box, then they couldn't do much. They could read files, they could write to the dataset, but they can't execute anything. And it's CH rooted to the dataset, which means that the only thing this user sees if you open it in like a file sharing, like FileZilla or something, it sees the root folder as this dataset instead of the actual root folder. So you have a root folder on the machine, which has all your OS things and executables and such. And then you have another folder in there, and you just say that, okay, for this user, I wanted to see this other folder as the root folder. So you hide everything else. In addition to that, I force the file sharing command. So if one of these were to fail, the other one would take over. You technically only need one. And also disable some other things like TCP forwarding, because otherwise you could use the server as a proxy, and X11 forwarding, because it's a security risk. For the torrent server, like I said, I use rtorrent, and it's been set up with systemd, which is the initialization system for Linux, well, the new one. And I use a systemd unit for service management, which is very easy to set up and just make sure that, okay, if the client crashes, it'll be restarted. When the computer is shut down, the torrent client is stopped beforehand and such. And those are the only files that are on the torrent server. because in Linux you have a home directory where all the user's files are, and I just pulled that from the file server. So everything is stored on the file server, meaning that if I were to set up the torrent server again, then I would need to recreate this one file, and that's it. Oh, my throat. This is the service file, just to demonstrate that it's not that difficult to set up working services. This does basically checks that, okay, if you try to start the service, see if it already is running. If it is running, just don't do anything. If it's not running, start it and place a lock so you can't start multiple instances. And sorry, killing me. And commands for how to stop it and such. I've also set a custom limit of amount of files. In Linux, everything is a file, and when you scale up torrenting, you're going to use a lot of files. So this is how the services are connected. You have the VM host in one location, placing the torrent server into the virtual subnet. You have the file server on another location, placing the NAS into the subnet. And the VPN server is running the subnet and giving both services access to the network. For both systems, I use a Linux firewall called UFV to make sure that they only have access to the IP address for the VPN and nothing else. So that if someone were to, let's say the VPN server goes down, then these won't start connecting to random things on the internet from their real IP. They will use their fake one instead. Okay, so maybe the more useful part of the talk, ZFS. It's fun. Next generation file system. You have support for a lot of cool things, like something called LZ4 compression. You have various compression algorithms, like zip, for example. In comparison, zip is a lot slower. This is really fast algorithm. It won't get as good compression rates, but it doesn't really matter. On a file server, very often your bottleneck is your drives, or the I/O to the drives. So when you compress and decompress on both ends, you will be transferring less data to read the same amount of data. So turning on compression will actually increase your speed on this type of system and not decrease it. And the CPU usage is negligible for this. You also have something called deduplication, which basically says, okay, if these parts of files are the same, then just write it once, and for the other one, just reference that block. It works really well. It uses a lot of memory, though. It uses 1.5 gigabytes of RAM per terabyte, because basically what it does is each block is hashed, and the hash is stored in a dedupe table. And it needs to keep this entire table in memory, otherwise the performance gets crashed. So it uses a lot of memory. And if you can't afford that memory, then you will get really, really, really bad performance. It also has RAID Z, which is like RAID 5, but has a few extra features. Like it doesn't have, RAID 5 has something called a write hole bug, which can make the drives uncertain of which copy of the data is the real one. You have datasets, which allow you to set properties on basically on folder basis. So you can set a property on one folder and say, okay, this folder should be compressed, this other one should be deduplicated, but in this subfolder of this folder, only the ABC user can write and such. And you can also set a flag called copies to a number, which means that, okay, files in this folder should be copied across multiple drives, so that maybe instead of having just 2 drives of redundancy, you have 5 for this file. Interesting in development context is that you have snapshotting on ZFS and it's pretty much instant. So for snapshotting, you do something like this, say that, okay, I want to snapshot my storage VMs before test folder. And that will just return and say like, okay, you have a snapshot. And now you can write to this folder and do whatever. But if you want to, you can roll back at any time. And I've been thinking about, like, if you have your entire environment in virtual machines on air, you can create snapshots, boot up your entire environment, and run a bunch of tests that may break data, may do other various things, but then just roll back to have a known state before the tests, and that way get consistent tests, because usually when you're testing end-to-end, your database has a lot of state, and if your database changes, then the tests might be failing because of that, or because the code, or something else. But with this, you will know the entire state of the system except code. So if something breaks, then you know that it's the code that did it. In addition, all ZFS folders have a .zfs folder, which is just a hidden folder. And from there, you can access that folder in any snapshot. So if you have, say, weekly snapshots for 2 years, then you can, in any folder, go into the .zfs folder and see how this folder looked like any week back 2 years. Yeah, and rollback is also really fast. So I think this could be an interesting use case, but obviously it requires you host your environment on, well, at least the files for your environment on a Linux server. Okay, that's pretty much it. Bit before time. Questions?
So how do you consume the content you download? Do you use some kind of private streaming service like Plex, or do you just browse the files?
I have that as well. If this, okay. So basically what is done there is there's a different VPN server somewhere else. And the file server is exposing another NAS to that one, which does all the content distribution. So this is purely the torrenting system, but these are parts of other networks as well. But it's just a way to separate things. And I've used Subsonic, if you're familiar with that, and a few others. For my local consumption of the services, I just use SSH as well, because then I get basically a folder with the content that is on this server, but the system doesn't know it, so you can use VLC or whatever. Okay.
You mentioned ZFS snapshot. How much space do those snapshots use?
Nothing to begin with, but all the changes you write that change to the snapshot as well. So basically, I think by default, a snapshot uses